You can see it, right? You can see it. You see the, remember the file was sent to you yesterday, right? So everybody should understand how to. Let's continue with, we have finished a lot of examples, lot of problems, right? Now let's continue with, we have finished what? 16, 17, 18, 19, 20, right? So let's continue with 21, okay?
Yeah, after seeing all those images, some objects are actually.
Let's do a number 21. Number 21. Find second order derivative for this function. So fx, so please copy it down, okay? Because this is important for you to understand. You have to show your work, right? You have to copy it down because the file only contains the answer keys, right? Does not contain any single steps, okay? You got to know how to find the answer, okay? This is hyperbolic sine or sinh, right? X squared, okay, x squared. You have to find the first order first. So what's the first order derivative? Right, by using the chain rule, right? Sinh derivative is cosine h, or hyperbolic cosine, right? X squared, don't forget, okay? Inside is x squared. And then times x squared derivative with 2x. Right? So this is the first order. So you can write this as 2x cosine h. Inside is x squared. Okay, this is the first order. Now you have to find second order, right? You have to find the second order, right? So second order, you have to use what? You have to use x times another function, right? You have to use what rule here? Product rule, right? Naturally, okay? So it's equal to 2 is a scalar, don't worry about that, right? X derivative is 1, right? 1 times cosine h x squared plus x times the derivative of these. You have to use the chain rule once again. Cosine h derivative is sine h, remember? Right? Not negative, but positive, okay? Of x squared times x squared derivative, which is 2x. Okay, 2x. Okay, so let's simplify this slightly. So you see 2. Inside is cosine h of x squared, right? Plus 2x squared, right? Sine h squared. So we have finished. Okay? We have finished. These are final answer. Okay, so final answer is you have to find second order. 2 times cosine h x squared plus 2x squared sine h x squared. So please copy down, okay? Because I will erase this in a few seconds. Okay? So please understand how to find the answer by using the what? The chain rule, right? The chain. Of course, here for second order, you have to use the product rule, right? Because x times another function, so naturally you have to use that. We have no other choice, right? It's almost automatic for you to apply the two rules, right? So final answer is this, okay? You have to, on the final, you have to box your final answer, okay? So this is the final answer. 2 cosine h x squared plus 2x squared sine h x squared. Okay, please copy this down because I want to erase this in a few seconds. Okay, now I want to erase it. If you have not copied down, please let me know. Please say it if you have not copied down. Okay, because I want to erase it. Lipika, have you finished? Lipika?
I got it.
Okay, good. Because I saw you just copying, so I can erase it. Thank you very much, Luca. Now let's take a look at the answer in the here. The answers, right? See, same thing, right? The answer for two inside, right? So 2 cosine 2x squared and 2 times 2x squared 4x squared, right? So 2 has been distributed in the answer, right? But it's same answer as my answer, right? Because I put 2 outside, right? The answer for 2 inside. So same answer, right? 2 cosine 2x squared plus 4x squared sin 2x squared. Okay? Now let's do the last one. Okay, let's do the last one. What's the last one? The last one you have to find what? You have to find the critical numbers of this function is x squared times e negative x squared. So how to find the critical numbers? Remember, you have to find what? The derivative is then less than equal to 0 solve for x, right? Now let's find the derivative first. Okay, by using the product rule, right? Naturally. So x squared derivative 2x. Okay, e negative x squared. Right, negative square plus x squared unchanged, and this derivative you have to use the chain rule, right? E negative x squared times negative x squared derivative is negative 2x. Okay, so you can simplify. Common factor is x e negative x squared. Right, common factor is now what's left? 2 minus x is gone, right? Minus 2x squared. Right? Or you can put 2 outside. Let's put 2 outside. Okay, we have 1, right? Minus x squared, right? X squared. Okay, right? 2 is a common factor, x is a common factor, e negative x squared common factor. So what's left here is 1. Here left is x squared, right? Minus, minus. So that's equal to 0, solve for x, okay? This is always positive. Remember, this is always positive, right? It does not contribute to 0. Now you have x equal to 0, right? And this equal to 0, you have 2 loops, right? 1, negative 1. Okay, so we have found the answer. Okay, 0, 1, negative 1 are the what? The critical numbers, okay, of the function. So we have finished. The answers are 0, 1, and negative 1. So please write down, okay? First, you have to find the first order derivative, and then less than equal to 0 solve for x. So you have 3 critical numbers, 0, 1, negative 1. Okay, so we have finished. I want to erase now. If you have not copied, please let me know now, okay? This is 0, 1, negative 1, okay? So let's compare the answer. Same answer, right? Negative 1, 0, 1, okay? So we have finished. Same answer. Now we can go back because we have finished a lot of problems, right? So here, this on the second page, right? 16, 17, 18, 19, 20, 21, 22 have been finished. Okay, so second page is gone, right? All you have to do is to look at the first page, okay? First page. So let's go back to the problem number 1, okay? To problem number 1. Here, if there is a limit for these, okay? So let's make, you have to do some algebra, right? If you put a 3 inside, you'll see that this is 0 over 0, right? So you can use what? You can use algebra, okay? Let's use algebra to find these. Okay, so this is limit. here you cannot use L'Hopital's rule, okay? You have to use algebra. L'Hopital's rule is for another part, okay? Right? You have to follow the instruction. If problem say you are not allowed to use L'Hopital's rule, then you cannot use L'Hopital's, right? So here we have to use algebra. How to use algebra? Easy. Times the x plus 1 in the numerator, right? And in the denominator, also this times what? X plus 1, okay? In order to simplify the fraction here. Okay, so this is, in the denominator is z times this. All right, for the numerator, you can distribute. So this is 8 minus 2 x plus 1. Okay, so there's no fraction here for the numerator. Now you can continue to simplify. Right, so this becomes limit as x approaches 3. Denominator copy down, okay? You do not change the denominator. Now what's the numerator? This is what? This is 8 minus 2x minus 2, so 6 minus 2x. Right? Right? 8 minus 2 is 6 minus 2x, right? Minus 2x. Now 2 is a common factor. Actually, negative 2 is a common factor. Let's put negative 2 outside. 6 minus 3. Right? It's negative 2x plus 6, right? Now you can what? X go to 3, you can cancel out these, right? Cancel out these. Now you can put a 3 inside because you can use direct substitution property, right? Which is equal to negative 2 over 3 plus 1, right? 4. So this is negative 1/2. Okay, the answer is negative 1/2. Okay, so we have finished. Negative 1/2 to get the final answer. Okay, to get the final answer. Negative 1/2. Okay, you cannot use L'Hopital's rule. You have to use algebra. Okay, don't forget that you cannot use L'Hopital's rule for this part. Okay, because this is from the very beginning of this matter, right? From the very beginning of this matter, we have not learned any L'Hopital's rule, right? You have to follow the instruction, okay? You got to use the algebra to find the limit, which is negative 1/2, right? Which is negative 1/2. Okay, so everybody should copy this down, okay? If you don't know how to solve this, you got to copy this down. If you know how to solve that, that's okay, right? But if you don't, please copy this down, okay? Because all these steps are not in the file, right? So I solved this for you. So please copy this down, okay? You don't want to waste your time here, right? So please do it, copy this down, okay? If you don't know how to solve it, right? Let me erase these. The answer is negative 1/2. I want to verify the answer. I hope we have the same answer. Yeah, see, negative 1/2, right? Negative 1/2. So we have finished. Okay, negative 1/2 in the final answer. Now, how to find the limit for the second one? You see here you have absolute value here, right? The idea is how to eliminate the absolute value. Okay, so this is limit as x go to 1/2. I think something. I think it should be x go to 1/2 from the. Okay, minus sign. See the minus sign, right? From the left. Okay, minus sign. So x go to 1/2 left. Okay, x go to 1/2 from the left. Right? Okay. 2x minus 1 absolute value over 2x squared minus x. Right, so you have to evaluate this limit. X go to 1/2 from the left side, and the numerator is this, denominator is this. So how can we simplify? Right, you want to simplify in order to evaluate this limit. So the limit is x go to 1/2 from left. Right, x go to 1/2 from left. What does it mean? This means that this is 1/2, right? 1/2. And x go to 1/2 from left side. Right, so it means x is what? It means x is less than 1/2, right? Less than 1/2. Right, because x go to 1/2 from left side means x is less than 1/2. Or put 2x over, that means 2x minus 2x is less than 1. Right? Minus 1 on either side, you can see that 2x minus 1 is less than 0. Right? So if x go to 1/2 from left side, 2x minus 1 is less than 0. This means that this is a negative number, right? So therefore, you can eliminate the absolute value. It becomes what? Negative 2x minus 1. Because 2x minus 1 is negative, so negative become positive. Absolute value is always positive, right? So inside is negative number, so absolute value become negative become positive. Remember, okay? Now this is x common factor. Okay, x common factor. Now you can what? Cancel out these. Same, right? Now x is 1/2. Okay, you can use direct substitution property. Negative 1 over plus 1/2 inside for the denominator, right? And the answer is negative 2. Okay. So we have found the answer for this limit is negative 2. Okay, negative 2. By using what? By using the property of absolute value. Because you know 2x minus 1 is negative, right? So absolute value is negative of negative number become positive. Right? So you have the answer, which is negative 2. Okay, so we have finished. The limit for the problem is negative 2. Okay, is negative 2. So let me erase this. Let me verify the answer. Okay, should be the same answer. See, right? Negative 2, right? Negative 2. So we have found the answer negative 2. Okay. Next. What's the problem? Problem is this. Limit x go to negative 3 from the right side. Okay, plus means x go to negative 3 plus, right? Let me see. Right, x go to negative 3 plus. Plus means x go to negative 3 from the right side. Okay? X squared plus 1 over x plus 3. Okay? So this is negative 3. Right, x go to negative 3 from the right side. Okay, let's say if we put a negative 3 inside, you will have 10 over 0. So the answer is either positive infinity or negative infinity. You have to decide a sign, positive infinity or negative infinity. You have to ask yourself, right? Now the numerator is always positive. Now x go to negative 3 from the left side. What does it mean? It means that x is what? Larger than negative 3. Right? Right. Now, so x goes to 3 from the left side, x is larger than negative. So what it means? It means that you add 3. X plus 3 is positive. Right? So the denominator is positive, the numerator is positive, the answer is positive infinity, non-negative infinity. Okay? Okay, the answer is positive infinity. So we have found the limit for part C, right? So it's positive infinity, non-negative infinity, okay? Because the numerator is positive, the denominator is also positive, right? So the answer is positive infinity, okay? So if you have a non-negative number over 0, the answer is either positive infinity or negative infinity. You have to decide which one is which, right? It's positive infinity. The reason is that x go to next to 3 from the right side, it means x larger than next to 3, or x plus 3 is positive, right? So the answer is positive infinity. Okay, let me erase these. Let's verify the answer here. Right, positive infinity. See? Right, positive infinity. Yeah? Here, right? Right, positive infinity. Okay, positive infinity, right? Yeah. Now let's do next one. Find this limit. Part D. Limit x go to 0. X plus 3. Sin x over x times x plus 1. Okay, how can we find this limit? Here you have to use what? Here you have to use the property of limit. The limit of product equal to the product of limit, right? So you have to use the property of limit. The limit of product equal to the product of limits. Don't forget that, okay? So we can write this as limit, and x go to 0. X plus 3 x over 1. Times the limit, and x go to 0. Thanks to x. Okay, the sign, right? Because x plus 3 sin x is numerator, x times x plus 1 is denominator. Right, you call the limit of product to product of limits. Why I want to write that? Because this is a famous limit, remember? This limit is 1. We have learned this, the famous limit in mathematics. Right? The limit of sin x over x as x approaches 0 is equal to 1. Right? So this part is 1. Now here you can use direct substitution policy, put 0 inside, right? So this is 3 over 1, right? 3 times 1, which is 3. Okay, so we have found the answer, which is 3. 3 times 1, right? 3. Okay? So you got to learn how to handle the kind of limit without using L'Hopital's rule, right? Without using L'Hopital's rule. Okay, so the answer is 3. Okay, so we have found. Let me check the answer. Okay? Okay, the answer is 3, right? Let me erase this, okay? Easy to find by using the three, right? See here. D, right? 3, right? 3. So we have finished. Okay? 3. See? Right? 3. Okay. This is next. Let's do next. So we have finished number one, right? A, B, C, D. Okay, let's do next. Here, you have to use what? The definition of the derivative to find what? To find the derivative, find F prime x, right? You must use the limit definition to receive. You cannot use any rule here. You must use what? The limit definition to receive credit. If you use the rules, you cannot receive, you can have 0 point. Okay? So we have to use definition to find derivative. So that's the definition. Okay? You can use rules to verify your answer, the right answer. Right? All right, so please write down definition for derivative with limit and h approaches 0, f x plus h minus fx over h. Okay, that's the definition of the derivative. So limit as h approaches 0, fx plus h minus fx over h. That's definition. Okay, don't forget. Now you can evaluate limit as h approaches 0, fx plus h. What's that? That's square root 9 minus 2 x plus h. Minus fx is this. Over h, right? How can we evaluate this limit here? You cannot use direct substitution property, because if you use direct substitution property, you get 0 over 0, right? So you have to use algebra. How to use algebra? Rationalizing the numerator. Remember, we have learned this. Right? This is technique here. Okay, so times 9 minus 2 plus h. Plus this, right? Plus square root number 2x. Okay, so this is the numerator. The denominator is the same thing, right? Times the same quantity, nothing has been altered, right? Times square root 9 minus 2 plus h. Plus square root 9 2x. Okay, so we're almost done, right? So you have to simplify in order to get the final answer, right? But this is straightforward. This is limit, don't forget limit sign, okay? In h approaches 0. Here you can use what? A minus b times a plus b squared minus b squared. Remember the formula, right? So this is a minus b is a plus b, so a squared minus b squared. So square root and square cancel out, right? That's why we want to use this method. It becomes 9 minus 2 x plus h. Minus 2 minus 2x. Number 2x. Times over h times this. Minus 2 plus h plus this. Okay, So let's simplify. Please simplify the numerator first. How can we simplify the numerator? How can we simplify the numerator? Easy to simplify. Why? Distribute, right? So let me write down here. Is 9 minus 2x minus 2h. Right? 9 minus 2x minus 2h and minus 9 plus 2x. Right? Minus 9 plus 9 minus 2x minus 2h is this is minus 9 plus 2x. So you can cancel a lot of things, right? 9 minus 9 is gone. And then negative 2x plus 2x is gone. So you have only negative 2h left. Okay, so let me write down. This is nothing but negative 2h, right? Negative 2h. Okay, and that's 2h. Now you can what? You can continue to simplify. This is h, right? And this is h. It's gone, okay? H in the numerator and h in the denominator same, they're gone, right? So therefore, you can put a 0 inside. You can use direct substitution property right now, okay? So the denominator, put 0 inside, the numerator is negative 2, right? This is h equal to 0, right? So this becomes 9 minus 2x. This is the same thing, right? Plus 9 minus 2x. You have 2 of them, right? See? 2, you have same square root 9 minus twice, so cancel out, right? You have negative 1 square root 9 minus 2x. You have found the limit. Okay, we find the derivative for this function in this. It's negative 1 over square root 9 minus 2x. Okay, so we have found by using this is the method you have to use on the final, okay? You have to follow the instruction, definition of derivative, right? So this is the method. Okay, in negative 1 over, you can use what? You can use the rule to verify. So let's verify this is the right answer by using derivative rules, okay? Let's verify here. So fx is write this as a power form, 9 minus 2x to the power 1/2, right? So you can use the chain rule, right? Find derivative, okay? F prime x one half down, right? And 9 minus 2x how to find the answer? 1 half minus 1, right? Negative 1/2. And times the derivative inside, which is negative 2. Right? 2, 1 half cancel out. So it becomes negative 1, right? This is a radical, 9 minus 2x. Same answer, right? Here you have negative 1 over square root 9 minus 2x. This is negative 1 over square root minus 2. So same answer. Okay, but this is not allowed. Okay, you are not allowed to use this method. Okay, you have to use this method. Okay, so please remember that. Okay, you have to use this method. You cannot use this method. Okay, this only can for you to what? For you to verify your answer, the right answer, right? But on test, you cannot use this method. You have to use definition. Okay, you have to use limit notation. You cannot apply the chain rule for this problem. Okay, so remember, you have to follow the instruction. The instruction is asking you to define the derivative by using the definition, right? So you cannot use the rule. If you use the rules, you get 0 point. Okay, you get 0 point. And the question for number 2, we have finished number 2 by using the definition of the derivative, right? It's quite straightforward, as long as you know how to do algebra, right? How to do algebra. So the answer is this. Okay. So now let me erase this because I want to continue here. Let's look at the answer in the textbook. Same answer? Same answer, right? F times x is equal to -1 over square root number 2x. The same answer. Okay? So f times x is indeed equal to 1 over square root number 2x. But here you have to use definition. You cannot use rules. If you use rules, even though your answer is the right answer, you get 0 point. Okay? Because you have not followed the instruction, right? Okay, so we have finished number 2. Let's look at number 3. Okay, number 3. Now, see here, you have to number 13, right? So look at instruction. For number 13, you can use L'Hopital's rule, right? But not for number 1, okay? Not for number 1. Okay, let's do number 3. Please look at the function. It's called piecewise defined function, right? Piecewise defined function. Please sketch this. How can we sketch this function? Piecewise defined function. We learned how to sketch piecewise defined function. Please sketch this function. Please do it now. Suppose you have not done it, right? Please do it now, okay? Sketch the function and find the limit. How can we sketch it? You have how many pieces? 3 pieces, right? First piece is for x less than 1. And the second piece for x equal to 1. The third piece for x larger than 1, right? So for the first piece is a line. For the second piece is a simple 0 in the number. For the third piece is square. It's a parabola, right? Now you can sketch it. Please sketch this function. Piecewise defined function. Or piecewise function. How can we start? Easy. Let's do it. Okay? Huh? Now let's do it. Okay? X, Y, and origin. Alright, so origin. Now you have 1. Now this is 1. 1 is a turning point, right? X larger than 1 is x squared. Okay, so x larger than 1 is x squared. X squared is the picture is 1, but 1 is not inside, right? Small circle, okay, small circle. All right, x larger than 1. See, the graph is x squared. X equal to 1, the function value is 0. X equal to 1, the function value is 0. Okay, function value is 0, right? Because x equal to 1, the function value is 0. So you have a small circle here, right? Because x equal to 1, the function value not 1, but 0. Okay? Now please sketch the first piece. Everybody please sketch the first piece. Negative 2x plus 3. Please sketch this piece. All you have to do is to find 2 points, right? X equal to 0, the value is 3. So suppose this is 3. Okay, this is 3. Right, x equal to 0, the y value is 3. How about what happens for x equal to 1? Is 1, right? So if this is 3, okay? Okay, so that's a picture. Okay, right, that's a picture. This is x equal to 0, y is 3. If x equal to 1, this will be 1, but 1 is not included, x larger than 1, right? So that's a picture. Okay, this is line, this is a what? Parabola opening up, right? And x equal to 1, the function value is not 1, but 0. Okay. Okay, so we have finished the sketching, right? Now please find AB. What's the limit of fx as x go to 1? Look at the picture. What's the limit here? You have to show the work, right? It's the work you have to show. Please write down, okay? First, let x go to 1 from the right side of the fx. Okay, so you have to know x go to 1 from the right side, x larger than 1. So you have to use the third piece, right? So it's limit. And x go to 1 from the right side. So x larger than 1, the piece is x squared. Right? So this is 1 square, which is 1. Okay, so x go to 1 from the right side, the limit is 1. Let's look at x go to 1 from the left side of the fx. Right, now x go to 1 from the left side, x less than 1. Less than 1 means you have this first piece, right? The piece is next to 2 plus 3. Okay, 3, sorry. Now you can put 1 inside, right? 1 for inside. So it's next to 2 times 1 is next to 2 plus 3 is 1. Right? So this you can use the direct substitution property. Next to 2 times 1 is next to 2 plus 3 is 1. Okay, so they are both equal to 1, right? So therefore we have found the limit. So therefore the right limit and the left limit, they are both equal to 1. So therefore we have found that the limit of fx as x approaches 1 equal to 1. Okay, so everybody on the final got to show work, right? These are work you have to show. Okay, first you have to find the right limit, then find the left limit. They happen to be same, right? So therefore, the limit of fx as x go to 1 is equal to 1, right? Look at the picture, right? But you cannot use the picture. You have to show your work. Okay, picture just help you to see it, right? But you got to show your work. Why the limit is 1? You have to show your work, right? Now we have found limit is 1. Okay, so A has been finished. How about B? Is fx continuous at 1? Justify your answer. The answer is no, right? Why no? The answer is no. Okay, no. Fx is not continuous. But why no? What's the value at 0? Equal to the value at 1 is equal to 0. They are not same, right? So there is no. Okay? No. Okay? the reason is this, right? The reason is that the limit of fx and x go to 1 is not equal to f1. Okay, so you have to find the limit of fx as x go to 1 is not equal to f1. Why not equal to f1? Because the limit of fx as x go to 1 is equal to 1. f1 is 0, 1 not equal to 0, right? So therefore, the answer is no. Okay, the function is not continuous at 1. Okay, not continuous. So we got to understand why not continuous. The reason is that the limit of fx as x go to 1 is 1. And the function value at 1 is 0, 1 not equal to 0, right? So the answer is no, not continuous. You have to show your work, right? You have to justify your answer, right? So the answer is no. Okay? By using that definition of continuity of function at a certain point, right? So we have found. Okay? Let me erase it because I want to verify the answer. Hmm? (3a), see? This is 2 by using definition of derivative. This is 3a. The answer is 1, right? The limit is 1, right? Limit 1x go to 1, the limit is 1. The function is not continuous at 1. The reason is why the limit and the function value are not the same, right? So first, the answer, the limit is 1. The second answer, the function is not continuous at 1. The reason is that the limit value and the function value are not the same, right? So the answer, the function is not continuous at 1. Or you can say it's discontinuous at 1, right? Now let's do the next one. We have a lot of time. Good. Let's do the next one. Let's look at number 4. Okay, we have finished number 3, right? So let's look at number 4. Okay, let's look at number 4. How can we solve number 4? How can we solve number 4? Right, everybody should learn how to solve this kind of problem, okay? For your final exam review, right? It's very important, okay? So fx, is fx continuous at 1? No, because the limit value is 1, the function value is 0. They're not signed. So that's why you have to so-called justify your answer, right? Now let's look at number 4. 2x is less than or equal to fx is less than or equal to x squared for all 0 less than x less than 3. You have to find the limit of fx as x go to 2. How can we find it? By using the famous squeeze cell, right? Famous squeeze cell. Okay, let's use squeeze cell. You have these, right? You have these. To x less than or equal to fx. Less than or equal to, right? So fx is between 2x and x squared, right? See, fx is between 2x and x squared. Now let's find the limit of when x goes to 2, right? So you can find the left limit. Limit x goes to 2 of 2x, right? 2x. What's this limit here? For 2 inside, right? By using so-called the Dirac substitution property, right? And the answer is 4. Okay. Now the right limit of x squared, x goes to 2. is also easy, right? You can put 2 inside, right? So 2 square. Okay? So what does that mean? This means that the middle limit is also equal to 4 by squeeze itself, right? So therefore, because they are signed, right? So therefore, the limit of fx and x goes to 2 is 4. Okay, we have found 4. Right, the limit of fx as x goes to 2 is 4. Why? The left limit is 4, the right limit is also 4, right? They happen to be signed, right? So therefore, the middle limit is also equal to 4. Okay? 4. So we have finished. 4. And hopefully we have the same answer. Okay, please copy this down. Okay, few seconds, not few minutes. Okay, the answer is 4. Okay, let's take a look at the answer in the textbook. Same answer? Yeah, 4. See, right? Found number 4. The answer is 4. Okay, 4. Let's look at found number 5. Okay, we have done number 4, right? So x go to 2, the limit of fx is equal to 4. Let's do number 5. Use the intermediate value sum, IVT, to determine if x fifth minus x cubed plus 3x minus 5 equal to 0 has a solution between 1 and 2. Okay, how to show that this equation has a solution between 1 and 2. It's hard to solve. Why it's hard to solve? Because this is a fifth degree equation. Fifth degree equation, we don't have any formula to solve this, right? So you have to use what? IVT to determine that you have a root between 1 and 2, even though we don't know how to solve it, right? So that's straightforward, right? You have to remember how to apply IVT, right? So fx equal to this. Go to copy this function down, right? X fifth minus x cubed plus x minus 5. Yeah. So you have to find, this function is continuous, don't forget, okay? Continuous. Because polynomial is continuous everywhere, right? Of course, this function is continuous between 1 and 2, right? So this function is continuous everywhere. Now what's f1? What's f2? Please find the value for f1, f2. Everybody please find these two values. What's the function value for f1? Put 1 inside, tell me the answer. Tell me the answer. Put 1 inside. Tell me the answer. What's the value? Put 1 inside.
-2.
What's the value? -2. Thank you very much. Right? Because 1 minus 1 cancels out, right? So 3 minus 5 is -2. Yes, good. Now what's the f2? Put 2 inside. Evaluate these. Everybody put 2 inside. What's the value here? What's f2? put 2 inside. What's F2? Please use the calculator or you can do it by. What? Tell me the answer. Sorry, what? I cannot hear you. What's the answer?
25.
25. Yes or no? It's 25, let's verify. 2 to the power 5 is 32. Right? Minus 8 plus 6 minus 5. Yes, right answer. This is 24. 13 minus 5 is 25. Good. Now this is negative, right? And this is positive. Right? So now you can pick one. C equal to 0. 0 is between negative 2 and 25, right? 0 is between negative 2 and 25, because negative 2 is less than 0, 0 is less than 25, right? So by IVT, there's a root. No, not C. Let's use M, okay? M. Okay? Now, by IVT, there's a C between 1, 2, such that FC is equal to M, right? So we have finished, okay? By IVT, right? What does IVT mean, right? F1 is negative, F2 is positive, and capital N is 0, is between negative number and positive number, right? So by IVT, you can find C between 1 and 2, such that F equal to M, M is 0. So the C is the root, has a solution, right? C is a solution between 1 and 2 for a function fx. Okay, even though we don't know how to find C, right? But still by IVT, we know that such a solution, such a root, such a 0 exists between 1 and 2, right? Even though we don't know how to find it, right? But that's okay. This problem asks you to what? Show that this root exists, right? The problem does not ask you to find this root, right? All we have to do is to show that this root C exists between 1 and 2, okay? We have finished. Let's do number 6. Everybody please do number 6. So we have finished number 5, okay? Use the IVT to determine if the equation equal to 0 has a solution. The answer is yes, okay? Yes. Let's do number 6. Find this derivative. Okay? But you want to here, see here, time, right? So what time? X squared is 2x, right? Derivative 2x, sine pi x. Plus x squared unchanged. Sine x is cosine pi x. Times tax derivative is pi, right? So we have finished. Okay, so 2x sine pi x plus pi x squared cosine pi x. Okay, by using the product rule and the chain rule, so we can find the answer. Okay, we can find the answer. Right? Let's do the next one. Tangent x over 1 plus x squared. How can we find derivative for this? Again, you have to use the chain rule, right? Y prime tan derivative is secant square, right? Yeah. Then you have to what? Find derivative inside. So how to find derivative for x over 1 plus x squared? By using what rule here? The quotient rule, right? So this is a quotient of two functions, right? So you have to use the quotient. Okay, so this is 1 plus x squared square. Okay, so please find the numerator. Simplify. Please find the numerator and then simplify. You find numerator and then simplify. The derivative is what? F prime g minus f g prime over g squared, right? So what's f prime here? 1, right? So 1 times, write down, right? F prime g is 1 times 1 plus x squared. Minus f g prime, okay? X times 2x. So what's the answer? Simplify. This is 1 plus x squared minus 2x squared, so this becomes 1. One minus x squared, right? Okay, so the answer is secant squared x over 1 plus x squared times 1 minus x squared over 1 plus x squared squared. Right? Simplify, you got to simplify, okay? Okay, so we have finished number 6. Okay, number 6. Let's look at the answer, okay? Let's take a look at the answer. Huh? Yeah. See? Right? For number 5, it what? Does. So there's a root by the IVT, right? It does, okay? Number 6a, see? Same answer, right? 2x sine pi x plus pi x squared cosine pi x. This is same answer, right? 1 minus x squared or 1 plus x squared squared, secant squared. So we have finished, right? Same answer. Now let's look at number 7.
Dr. Yao, it's 7.
So number 7, the answer is 1/4. Huh?
It's 738.
Okay, so, sorry. So we have finished number 6, right? So tomorrow we'll start with number 7, okay?